Hey there, this video is about passing data by reference into a function in C++. And this covers sections 6.10 to 6.13 in the Gaddis textbook. Now, we've talked before about passing data into functions via the parameters, and we've said a lot of nice things about passing by value, which is the normal thing. You're copying data into these new variables. They are independent, right? The variables in one function are separate from the variables that are parameters in your other function. That gives you a lot of security. That gives you a lot of safety. It's good for organizing a team that people can work independently. Now, passing data by reference is an alternative to that basically breaks all those rules. So we don't do this all the time, but in certain circumstances, this gives you some power. So you should know about this too. Passing by reference. When you want to make a parameter be passed by reference, instead of the normal pass by value, it's going to look like this. Here's my function prototype. There's one little change here you've probably seen already. You have a good return value for type, of course. You've got a good name for the function. You've got a type in the prototype for the incoming parameter. And the new thing here is you tag it with an ampersand to indicate that I want that to be passed by reference instead of the normal pass by value. So what does that do? Passing by reference is a strategy in which a function accesses the original passed variable directly, not a copy. Now you do this, now you don't have two separate variables. Now it actually just is one single variable, maybe under a different name. And the critical thing is that this will now allow you in your function to change the values in the calling environment. So if I have a main function that's calling, my new function can now actually change the variables back in main of whatever was passed in because it's the same thing. A couple of reasons why you would want to do that. You can use that to simulate multiple return values. We pointed out that functions can only return one single piece of data. That's the entire mathematical definition of a function. But sometimes in programming, you really do want to hand back 2 or 3 pieces of information. So you could do this. You could make 2 or 3 parameters, make them all references, so you can change them, and then you have these variables back in main or whatever, and your function here can change them, so now main has those 3 new pieces of information handed back. That could possibly happen. I do that in input functions quite a bit, actually. Probably the more important thing is that this can save memory on large data structures. Now, so far in our course, we're really just handling fairly small amounts of data. We're handing around an int that's 4 bytes. We're passing around a double that's 8 bytes. That's more or less it. But what if your program was handling a music file? Okay, like a standard music file could be 3 megabytes, maybe 5 megabytes in size, 5 million bytes. And so if you had a data structure like that and you pass it into a function the normal way, pass by value, you'd have to make a copy. You'd have to copy all 5 million bytes into a new variable. And then you call another function and you're going to make another copy of the same 5 million bytes. So very rapidly, you're going to wind up using up lots and lots of your memory system. And you're also going to be using up a lot of time on the processor making those copies when you kind of don't really need to. So by passing by reference, the function's going to get access to the original data and not a copy, and therefore save memory and save time, which is great. How does that work? So if you remember, like the very first day's lecture in our Starter C++ programming course, we talked about the layout of memory and how every byte in memory, it has a value being stored there, but it also has an address indicating where it is in memory. Well, pass by value hands in the value that's in a location, but passing by reference hands in the address. And that's why they use an ampersand to indicate that. The ampersand indicates you're really just passing the address in, and then that new function knows where that memory location is and can go access it and change it, can read it, can write to it, whatever it wants. So you're actually literally passing in the address of where the thing is in memory, and then this function can go find it and do things with it. So that's interesting. There's a lot of power there. But of course, that breaks all the rules that we were complementing passing by value with, the security and the safety and the organization of your team, that two different people can't mess up each other's works. And so having broken that, you lose all that safety. There's quite a few risks to passing by reference. Is now one function can change another function in a way that you don't expect maybe. One programmer's mistake can now affect another programmer's work, which isn't great. It's hard to track the effects of one particular function call because now it can affect a bunch of other functions. It's very easy to introduce subtle bugs. Now, there's some kind of bug in my program. Now I don't know whose function is to blame. Is it Alice's? Is it Bob's? Is it Kathy's? Is it Dennis's? So you might need the whole team together to track down where the screw up is when functions can modify each other. So as a result, you don't normally do this. You normally use pass by value because it's safer. I would only pass data by reference if I had a very specific, clear goal in mind that I either needed multiple return values really, or if I was passing a big block of data, right? So if I specifically want to say yes to one of those things, then I pass by reference. If I'm unclear or I don't have a specific reason, just do the normal thing with pass by value, and it's a lot safer. Now, I'll just make a small comparison to other languages. Other languages don't always have this capacity. If I think about the Java language, you don't get a choice there. In Java, you're passing data into a function, the fundamental data types, the basic stuff like ints, floats, chars, bools, they always get passed in by value. There's no other option. There's always a copy. And anytime you're passing in a larger object, they're always passed in by reference. You don't have the other option about that either. But C++ gives you the choice and gives you the power. C++, you can choose whichever one you want, and that's kind of the philosophy of C++, is the programmer has full power over everything, whereas a language like Java, kind of is trying to do some stuff for you, and therefore you don't have that freedom. Both are reasonable strategies, but C++ gives you the power. You get to choose. So here's program 625, which is the first program that uses a reference variable as a function parameter. So of course there's a main function, and on line 7 you can see there's a prototype for a function called double num. It's a void function, doesn't pass anything back for return value. And the parameter, there's just one parameter, and the type is integer reference. So obviously you see int ampersand there, and I would pronounce that out loud as integer reference. It's not an integer value being copied in, it's an integer reference, which is to say a memory address location being sent in. Integer reference, two different types of things. So here's the main function, and it's setting up an integer called value being set to 4. It says in main, value is 4, of course. And it says now calling double num, calls double num. So it's going to jump down to double num. And here, the integer reference is being called refvar. But the thing is, that's really just another name for this value, right? Refvar is literally holding the address of where this value is. So this function can do whatever it wants to it. And what it does here is it's saying, take that refvar, wherever it is, and we're using combined multiplication assignment here. So multiply that thing by 2. And then, of course, you jump back into the main function here. And right after that, it says, now I'm back in main, value is value. Hopefully you know what's going to be there, right, based on what we just said. We should test that. Okay, so here's this program 625 with the first reference variable that I would like to test. Now, to highlight the difference in what's happening here, I'm going to modify this program to take out the reference variable. So I'm going to take out the ampersand in the prototype, and I'm going to take out the reference variable, the ampersand, in the function definition. Okay, so this is not actually the program that's in the book now. I can compile this, of course, and so this parameter here is getting passed in by value right now, which is what we've talked about before, and it's making a copy, and this thing in this function here is a different variable, and you cannot change what's in main. So when I run this, right, it says in main the value is 4. We called double num. It did something with that parameter, but that doesn't really change what's in main. So now back in main, the value is still 4. We've seen that before. But the interesting thing with reference variables, and I'll put it back in the form that the book has it, right, is now that's going to be different. So I can compile this and run it. now that function can change the value in main. So in main value is 4, now calling double num, we should look at that more closely, right? So double num takes that in, which is really just a reference to this value. It's the same thing actually, multiplies that by 2, and now back in main value is 8. So that's the primary purpose to a reference variable, is it allows you to change the variable that got passed in, and that's a big difference. All right, so a little bit more power when you're using reference variables. A couple notes about that to be clear. Each reference parameter must contain that ampersand to indicate that you're really passing an address. If I have 2 or 3 parameters and I want them all to be references, they all have to have the ampersand tacked onto it. You got to use the ampersand in both the prototype and the header, right? The prototype at the top of the file and the header where you actually define it. If you've got it in one place but not the other, you're going to have a compiler error, because to the compiler, it's not going to look like the same function. I guess you might have a linker error, actually. It might compile, and then right at the end, you might have like an ID1 error when it doesn't link on you, is what could happen. The argument being passed in to a reference parameter must be a variable. It cannot be an expression or a constant. So what that's saying is variables are a thing that's in a location in memory, and the reference using function has got to have a place in memory that it can access and change. If you just pass in the number 5, that's not a place in memory that has an address. It's just a number stuck in the code, and that's not permissible, and that won't compile. It makes sense. You can't put 3 plus 2, you can't put score 1 plus score 2, because that's, again, not a single variable with a single location in memory with an address. Okay, so it's got to be a variable that has an address, not anything more complicated. And again, use this only when appropriate. Don't make every single variable a reference. Use it only when the argument needs to be changed by the function. So a lot of the time I ask myself this parameter, for the function to do its job, does it need to change this variable? And only if the answer is yes, do I make it reference. So generally speaking, I only use that in an input function, right? Input functions are going to take information from the user. They need to store them somewhere. A variable has got to change to store it. And that's the cases where I tend to use reference variables are for input functions. Tell me the variables where I should store my user data. Again, the other reason I would use it is for a very large data structure, but we actually don't do that in this part of the course. So in second semester programming, that starts to become more important. But at least for this first semester programming, I just use it in my input functions to tell me where to store the data. All right, so we are near the end of chapter 6, introducing functions, and we know how to get data into a function, either passed by value or reference. We know how to get data out with return values. And there's a little bit of grab bag at the end of a chapter of other stuff you ought to know about, stuff that we don't use a whole heck of a lot. One option is default arguments. Is you can make a function prototype that looks like this, and you notice the difference is we've got type equals an actual number. So you might see int equals 5 there in the prototype. And what that's doing is it's setting up a default, right? If you don't tell me anything else, value that gets passed into that parameter that's going to save another programmer some time, because now they can just leave the parameter blank and you just use this number instead. You don't even have to specify it. So you're writing a function maybe for other programmers to use, and this will just save them a little bit of time. If there's some number that normally gets used, then they can just leave it blank on the function call. So that gets defined in the prototype like this. It simplifies function calls in some situations. You can do this for multiple parameters. You can write int equals 5, comma, int equals 10, comma, whatever. And the tiny little detail, I don't know, you may never run into this. If you have a parameter list and you want some of them to have these default values like this, and you want some to not, then the default arguments, the ones we're talking about here, have got to be at the end of the list. So you might possibly see int, comma, int equals 5, comma, int equals 10, and it's got to be in that order with the defaults at the end. If you think about it, if you try to leave the other stuff blank, it's not going to know where the other variables start. So if you think about trying to write a compiler, you'll realize that trying to do it in another order just doesn't make any sense. So the defaults have to be the last things. Again, that's a really fine detail you probably never run into. Sometimes we do this. Okay, so here's program 624 with an example of this. This program demonstrates default function arguments. And you have a function here called display stars. And the goal of this function is going to print like trying to print a flag on the screen made out of asterisks. You want it bigger, you want it smaller. So it's going to take two integer parameters. And the first parameter is the number of columns in the flag. And the second parameter is going to be the number of rows up or down in the flag. And you can see we're using default arguments here. So if you don't say anything else, you're going to get 10 columns. And if you don't say anything else, by default, you're going to get one row. So here's the main function where that gets called a couple times. Line 10 calls display stars, and you notice there was nothing put in the parentheses. And if you leave that blank, you get the default arguments. So how many columns and how many rows will that be? Okay, and then we call it a second time. We call display stars with just 5. So like we were just saying with that detail, that right there is going to be the first argument will be this non-default, this 5, okay? And the second argument, you'll get the default. So how many will that be? How many columns and how many rows? And then on line 14, we call display stars and actually specify both parameters. So you can see right there how many columns and how many rows you're going to get. Here's the display stars function, just to be clear, right? The first parameter is columns, calls for columns. The second parameter is the number of rows. And so to print a two-dimensional figure like this, we use a nested loop. I think we've seen that before. So basically the first for loop is iterating over the rows. So we've got a counter called down. How far down have I gone so far? And then the second for loop is iterating over the columns. So you have a counter called across. How far across have I gone so far? And each step in that nested loop, you print one star. Right? You get done with one row, and then we print an end line to get down to the next line. We should try that. All right, here's program 624 that uses these default function arguments in the IDE. So I will compile this. That looks good. Okay, maybe this would be good in the debugger, actually. So put a breakpoint here. And I think what I'm going to do is I'm going to put watches on these calls and rows parameter. Right, the parameters that are coming into this display stars function. And of course, if I'm in main right now, that stuff is out of scope, doesn't exist yet. But when we jump into that function, it will. I think I can just use the keyboard here to control this. So we're about to jump into display stars. We've left the parentheses blank. So when we get into display stars, what do you think calls and what do you think rows is going to be? And the answer is, right, it is whatever the defaults were. So if you leave it blank, that's the whole point of the defaults. You don't type anything here, you get 10 and 1 for your parameters. So we're going to see a little flag here with 10 columns and 1 row. I'll just step through that function down there. So the loop's happening there, printing up some stars, but you only get 1 row of it because that was the rows parameter. Okay, we'll come back. So the next one here, if I call display stars 5, and we jump down here, what will columns be and what will rows be now? Let's see. Right, so columns is the 5 that got passed in, and since we didn't type anything for the second parameter, that's going to be the default of 1. So here calls is 5 and rows is still 1. And we'll step through this, and you'll see the flag get printed out with 5 stars in just 1 row. And we'll come back here. Now obviously, if you, the column line 14, right, you specify these two things. Now columns will be 7 and rows will be 3, of course. So you can see that right there. And now, I'm going to get 7 columns, but there's 1 and 2 and 3 rows of it. Like that. Great. Okay, so that's the point of default arguments, is that, maybe if most of the time I just want one row of stars, then, other programmers would be saving a little bit of time of just leaving it blank. And you get the 1 for free. But on the day that you want 3 rows instead, like that last example, just type down the 3. Again, I actually don't use this a lot. I tend to use overloaded functions more for this kind of job. But it exists in C, it exists in C++, so that's perfectly fine. And of course, don't forget, I was running that in the debugger, so it was kind of slowed down. If you run this program at full speed, then all of those flags just immediately appear. Right? The nested loop, of course, runs really, really fast, and it just looks like the whole thing just appears on screen, of course. Okay, last detail, I think. So there's this idea, and this is a little bit of exotic. I actually very rarely use this, but you should know about it in case you see it in code. The idea of static local variables. Okay, so you're defining a variable in a function. You're defining a normal local variable. You can tag it with the keyword static in front. You have the normal return type, int or float. You give it a good name, but the new thing here is this keyword static out in front. So a static local variable is a local variable that stays in place in memory between function calls storing a value. Remember that what we've said previously about local variables is that they don't exist before you get into it, and then when the function ends, they get recycled and scrubbed out of memory. They're gone. And then hypothetically, if you call that function a second time, it's going to make a brand new variable for the local variable and the parameters for what it's worth. And then at the end of that function, it'll get scrubbed out of memory. So static is saying, don't do that. Don't scrub it out of memory at the end. Leave it in place. Leave it static in one place in memory, even when you're outside the function. So this is quite different. We don't use this very much, like I said. Sometimes this is useful. It makes for a good test question, honestly. So you should know about this. And in other contexts later on, you're also going to see this static keyword come up. And generally speaking, static means this is in just one place in memory and it stays there. So here's an example of that, program with a static local variable. You've got this function called showStatic, just to demonstrate this. You got a for loop to make 5 calls happen. Hopefully you can see that. You're going to call the showStatic function 5 times. So the interesting new thing here down on line 23 is you have a local variable that's been declared to be static. So you print out stat num is whatever, and then increment it. Now remember, normally you get in there, stat num would get created, have something in it, and then after this function is over, it just gets scrubbed out of memory, it doesn't exist anymore. But this is going to be different. Okay, so here is program 622 in the IDE, our example of testing out a static local variable here. And of course, that's down on line 23 here. I'm going to make a couple changes to this code for the demonstration. Now, number one, I'm a little bit uncomfortable with line 23 because the variable is uninitialized. And remember, at least normally, if you don't initialize a variable, it's got random garbage, and I have no idea what it's going to print out. So just because I'm a little bit unsure about that, for argument's sake, I'm going to initialize that to 0. And then the other change that I'm making is I'm just going to remove the static to begin with so we can compare the difference. So right here is how we normally see local variables. And I'll compile this. Of course, this is fine. Get that space back. So we'll just think about this. So as this function gets called 5 times, the CPU is going to jump in here, make stat num in memory, assign it 0, and then it's going to print out stat num is 0, and then you can increment it, becomes 1, but as the function ends, that variable just gets trashed, and that memory location gets recycled, and now it can be used for some other variable, and it doesn't exist anymore. And the second time you call the function, it's going to make a new variable called stat num in memory. It's going to assign it to 0. It's going to print out stat num is 0. It's going to increment it, and as the function ends, it gets trashed. So every single one of the 5 times you come through here, you're really remaking a brand new variable starting at 0. So when we run this, I think I compiled it right. it winds up saying, for the 5 calls, stat num is 0, stat num is 0, stat num is 0. It's 0 every single time because it's getting reconstructed every single time. And that's the normal thing with variables. Even if you did something with it, it's just got trashed when you get out of the function and that data is gone. So the new thing, of course, was to stick a static on here. Shows up in boldface. That's a C++ keyword. So now you get in here, you have a variable set to 0. I don't even need the equals 0 there for that, actually. It's a little secret. But it gets set to 0. It says stat num is 0. You increment it to 1, and when you get out of the function, it is not trashed. It stays in that one place in memory. And now when you call it the second time, right, it doesn't have to do this, and it doesn't have to initialize it again. We already did that. And it's going to say stat num is 1. And it gets incremented, not recycled, and then that same process happens every time you call the function. So I can call this, I can compile this. This is the form that the book has it. And when I run this, now it says stat num is 0, and stat num is 1, and stat num is 2, instead of recycling it every time. It stays in place, static in one place. So you maintain that data between function calls like this. So I think maybe in the past that was more useful. There's kind of better techniques nowadays. So I can't remember the last time that I used a static variable, but it still exists in the language, and you should know about it in case you run into it maybe in somebody else's code. Okay, so that's chapter 6 on functions. And at this point, we can handle larger programs with more code because we're going to be separating them out into fairly small slices. I'm hoping like around 7 lines. Again, 2, 3, 4, 5, 6, fine. 8, 9, 10, 11, 12, fine. But, fairly small slices that fit on screen at once. And most of the time, if you're passing data by value, right, everything in the entire universe that you can access that you need to know about is just in that slice. And you can mentally focus on just that thing for a little bit and ignore everything else out in the world. And that'll give us a lot of mental focus and a lot of clarity and a lot of safety and a lot of security. So many, many benefits, and allow us to work on a large team independently. So at this point, our programs look quite a bit different, which is great. I would recommend that you read book chapter 6. There's a lot more examples of function calls than we had time to show here, so you should look at all those things. Test yourself with the review questions at the end of the chapter. And then for my students, there's a programming challenge the first time you're writing your own functions, and look that up on the learning management system. Read that specification very, very carefully and make sure you're creating exactly the functions that are being described with the right parameters and the right names and the right return values and all that kind of stuff. So my students would get together for probably this lab here, introduction to passing by reference, the somewhat more exotic advanced way of passing data in a function where you can change the original variable because you're actually passing the address of it. And so the goal of this program, if you think about it, this program should take a pay rate, and there's really just one function that does this stuff, takes a pay rate and hours worked, so 2 pieces of input, and it's going to compute the gross pay and the net pay after subtracting for 15% withholding. So notice that that's 2 pieces of data that we would like to pass back. We cannot do that with a return value because there's only ever one return value from a function, but you can do that by using 2 reference parameters. So the function will take in your input and then set one variable to the gross and one variable to the net by reference variables, and that's how it gets the 2 pieces of data back into the main function. So a pretty good example of using reference variables. Again, we don't use that very much, but when there's a very clear purpose to it like this, then we would use a reference variable. So that is the story of how you manage larger amounts of code with well-defined functions that hopefully just do one job and are pretty short. Now, the other part of this story of larger programs is how do you handle larger amounts of data, right? Again, we've just been using a couple variables at a time, but professional programs, they need hundreds of variables. They need thousands of data points. And when we come back in the next video, we're going to start in on chapter 7, and the basic way you do that is what's called an array. It's very, very simple to say, hey, give me 10,000 variables. It just takes one line of code. Very, very simple. So that'll give us some additional power. Probably arrays are pretty, are probably the way that more data gets saved than just single variables, actually. So that's pretty important. So I will look forward to the next video as our programs get a lot more powerful when we get to use arrays in Chapter 7. I'll see you for that.